Alright, so we're in chapter 4, which is system of equations, solving systems of equations, and this is 4.2, using the substitution method to solve a system of equations. And this is going to talk about what it looks like with a system of equations with no solution using the substitution method. So what does it look like? Because we know that with a system of equations we could have one point as a solution. We could also have no solution where they're parallel lines. We could also have a situation where they're the same line. So using systems of equations and the substitution methods, what does it look like when we have no solution in our system? Let's take a look. We're going to fast forward past a couple of these videos that we've seen. Essentially, here's the way to use the substitution method. Solve one of the equations. Step number 1 is right by the star. Write one of the equations as x equals this. In other words, solve for x. You can also solve for y, but this example says solve for x. Replace that x into the other equation, and then solve for y. Tell me what the number is then for y. Y equals some number. Take that number and replace that value of y into the either original equation, and then solve for x, because you'll have just a number for x. And there's your solution, x and y solution. And then you can double check your solution in both original equations. So that's what we're going to do. So let's go down here to this one here. I've skipped a couple of these only because, in fact, I think I asked you to do that one for work coming to class. So let's try this system of equations. Solve. Let's see, and remember that if I say solve, you say x and y equals something. We've got to have a solution of a system of equations has an x and a y. Don't just stop at x, don't just stop at y. Tell me what x and y are. Alright, so for this one, we're going to have probably no solution, but just remember that. And we're going to say, let's see, if I've got a system of equations, y equals negative 1/2 x plus 3 is my A equation. My B equation is 2x plus 4y equals 5. I'm using the substitution methods because I've got A solved already for y. Y equals some number. So I'm going to take that stuff there and substitute it in for y. So I'm going to rewrite my B equation and say my B equation is 2x plus 4y equals 5. And I'm going to substitute in for y right there, this stuff here, because we got y equals something already. And now I know we've got a fraction, but don't worry about that fraction. We can either clear the fraction, but if we clear the fraction, we're not really solving for y, and we can't use the substitution method with this side. And we would have to use a different method. But for right now, we're already solved for y, so let's go and substitute in right down here. So I'm going to say 2x. I'm going to still say 2x plus 4 times y. What is y? We're going to call y negative 1/2 x plus 3. And now comes a little bit harder part because we kind of moved stuff around, so we've got to really just pay attention to what we've got left. We've got left equals 5. All right, and now we just distribute this 4 to the x and the 3, and 4 times 1/2, kindly enough, turns into just a whole number. So now we rewrite whatever we've got left. I got 2x plus 4 times negative 1/2 x is positive times a negative, gives me a negative. 4 times 1/2 is 4 over 2, or 2. 1/2 of 4 is 2. We've got the x still there. Distribute the 4. Positive 4 times positive 3 is positive 12. Equals 5. And now we just combine like terms because we've got x terms only and we've got numbers, so we can just solve for x, right? Alright, 2x minus 2x is 0. Hang on a second. Plus 12 equals 5. Holy cow, what happened here? 12 equals 5? When does that happen? Look, I think what we need to do is probably just go back and double check. Did I do this right? 2x plus 4y equals 5. There's my green. And I'm substituting in my y. Y equals negative 1/2 plus 3 goes right in here. 2x plus 4 times y equals 5. All right, well, I did that correctly. So that one's all right. 2x plus 4 times negative 1/2 is negative 2x. 4 times 3 is 12 equals 5. All right, and then 2x minus 2x is 0, so that goes away. So I got 12 equals 5. What happened here? Well, this is an example of what happens when our system is a no solution. if you get something that comes up with 12 equals 5 or something crazy like 17 equals 3 or 0 equals 12 or something like that, then you have to say that that leads to no solution. Before I do that, though, I would go back and, just like I did, double check everything that I did and say, well, you know what, everything I did is correct. So 12 equals 5 means that there's no solution. And why does it look like it's no solution? Well, you know what, let's keep the red line the way it is. So we'll just kind of keep that there because it's already in y equals mx plus b format. Let's convert the green line into something that's familiar as well. 2x plus 4y equals 5 is my b line, and we're going to convert it into y equals mx plus b format, or slope-intercept form. So to do that, we've got to have 1y equals everything else, so we've got to move the 2x over to the other side, subtract 2x on each side, and I'll have 4y equals 5 minus 2x, and we're going to say 4y equals negative 2x plus 5 because we're looking to get it into y equals mx plus b format. We've got to divide by 4 because we want just y on the left side. Y equals negative 1/2 x. Negative 2 divided by 4 is negative 1/2. Plus 5 divided by 4 is plus 5/4. Now don't worry too much about that fraction because really all we're doing is comparing this green line, which is our B line, to our A line. Here's our A line. What's our slope of the A line? Negative 1/2. What's our slope of our B line? Negative 1/2. Same slope. So they're going to have the same rise over run, rise over run, rise over run, and in fact it'd be rise over run because it'd be a negative 1/2. But the 3 is our y-intercept here. 0, 3 is our y-intercept for the red line. 0, 5/4 is our y-intercept for the green line. They intercept at different places. So if we're looking at it in a graph, let's see, the red line, well, I'll start with the green because I've got green here. Green line would intercept probably right about there, and 1/2 would be maybe something like that. The red line would be something like this, intercepting at 3, a little bit more than 5/4, and it would have the same slope. So therefore, these would not meet, the red line and the green line would not meet, and therefore they have no solution, which means the same thing as 12 equals 5 in the substitution method.